يشوف القضية تبعته من بيته ويشوف كل الإجراءات ويشوف المحامي شو بيحكي له شو قدم له شو صار فيه. شكرا يعني.
شكرا جزيلا مراد. طبعا هاي تجارب في موضوع الربط الإلكتروني وموضوع تقديم خدمات إلكترونية. بنتأمل إنه نشوف تجارب أنجح في المستقبل أو ناجحة مثل هاي التجارب. فهلأ بدنا نفتح بس باب للجمهور إذا في أسئلة، بس بنتأمل من كل شخص بحب يسأل يعرف.
هذه الجلسة راح يكون متعلق بتجارب ومشاريع. التجربة الأولى متعلقة بتجربة ربط قواعد البيانات الضريبية في إيطاليا في مدينة ترنتو. طبعا راح يتحدث معنا الأستاذ الدكتور بوكيه، باولو بوكيه. بعدها راح يتم الحديث عن تجربة خدمات الدفع والتسديد الإلكتروني، وراح يتحدث عنها المهندس إياد قمصية. أبدأ بالتعريف بالضيف الأول، وبعد السيشن الأول بنعرف بالمهندس إياد قمصية. بروفيسور باولو بوكيه بروفيسور في علوم الحاسوب، يدرس سيمانتك تكنولوجيز في البزنس والمانجمنت سكول في جامعة ترنتو في إيطاليا، ومؤسس شركة أوكام، اللي هو منبثق من مشروع أوكام بروجكت سبين اوف كومباني. يعني هي شركة كانت موجودة في الجامعة ومن ثم انطلقت خارج الجامعة. وزي ما حكيت يعني راح يتحدث لنا اليوم عن تجربة ربط قواعد البيانات الضريبية في إيطاليا. قبل ما يتحدث طبعا يعني الكل من السيشن الأول والثاني يمكن في وضوح لأهمية النواحي المالية في الحكومة الإلكترونية. يعني في عندنا القضايا البنية التحتية والقضايا التقنية والقضايا التشريعية، وفي جزء مهم جدا لأنه معظم الإجراءات لها علاقة بالنواحي المالية والدفع، وإذا كان أي خلل في هذا الجزء ممكن يسبب مشاكل متعددة. يعني يمكن شوي بحكي مع زميل إلي بقول إذا كان وزارة الداخلية حبست واحد سنة بالغلط مش راح يبطل مواطن فلسطيني يعني، ولا راح يهاجر أظن. بس إذا في بنك انسحب من حسابك من البنك بالخطأ 10 دنانير، أنت راح تفكر بشكل كبير جدا أنك تحول لبنك آخر. ولذلك القضايا المالية مهمة جدا. فمنرحب الآن ببروفيسور باولو.
Thank you very much for the introduction, even though I'm afraid I only understood my name in my university, but I'm sure it was okay, of course. So I will give this presentation on using semantic technologies in a very special field of the government, which is tax assessment and tax investigation. But the real topic is about data integration using semantic technologies. And since in most e-government services you need data, and you need to put together data from different applications, different services, different formats, maybe from different locations, I think the topic is broad enough also for people who are not directly interested in taxes. I'm here with a double hat. One is from the University of Trento, as I thought I understood from your introduction, and the other is as the president of this startup company called Occam that is involved directly in the project that I will present today. I'm afraid I cannot speak in Arabic, as you can see. Speaking in Italian would not make much sense, so I will stick to English and we see what we can do here. So this is more or less what I wanted to say. I will tell you briefly about the scenario, so how tax collection works in my region, Trentino. Then I will describe the approach we followed to provide a new innovative solution for tax inspectors so that they can find evaders or people with irregular positions with respect to tax paying more efficiently. Then something about the project I was talking about, where we've done this for the local regional tax agency. and then some conclusions about the work. So, this is the situation we found about 1 year ago. I think it's very typical in many tax agencies. I'm not sure about other countries, but in my country for sure this is the case. Maybe, I don't know, Italy is not famous around the world for the willingness to pay taxes. No, actually, my fellow citizens don't like to pay taxes in general. We had one minister who said that paying taxes is a beautiful thing, but he was immediately removed from office, officially not for this reason. So it is a real problem. We have a tax evasion which is around 180 billion euros per year, which is a huge amount of taxes. So it is a real problem. In the past, maybe this was not that bad because it was a moment where everything was growing very fast. But in this moment, being able to collect part of this money and reduce evasion to a normal rate is a priority for our country and for sure for our region. And the reason why I'm insisting on the region is that the region Trentino has a special autonomy with respect with the central government, so that basically 90% of taxes collected in the region stay in the region, which means that, and this is the only funding that the region has for the activities, for their administrative duties. So it is very important that even locally the tax collection is quite efficient, because otherwise the region would lose the very high standards that, and also high amount of money that he had in the past. So we have a local agency called Trentino Riscossioni. It's a small agency, and they are in charge of finding tax evasion and collecting taxes. The point is that this task, as you can imagine, is not completely trivial. First of all, because they have hundreds of potential sources of information. Okay, it's not just a tax declaration. You need more. You need to be able to build a profile of a citizen and understand not only the official income of the person, but is also the lifestyle, is other properties, is connections with other people that might be used as a way to hide properties or other activities. So it's really a very rich area with a lot of data potentially available. And the very sad thing is that today, even to collect the basic information about a single potential tax evader, it takes about 1 month. Not 1 month every day, but basically it works that the tax inspector has to send a request to each administration and to have information about a person, for example, or a company or whatever. And it will take about a month to collect this information, put it probably by fax, so not incredibly efficient. And then they need to work on faxes to put together the numbers. And it takes about a month just to create a profile, which is extremely inefficient. And they don't have any tool for exploring quickly, maybe not extremely in a very precise way, but at least to have a general idea of all this information to start with, so that they can immediately discharge candidates which are unlikely to be evaders or to be big evaders, and focus on the right people. And this results in many things, including a lot of frustration. I spoke to many of these tax investigators, and if, for example, some of the information is requested to administrations outside the region, it may really take something like 3 months to have the information. So this is not acceptable. What I wanted to say here, this picture is just a picture from the web. It's not a tax evader in Trentino. Okay, is that this activity is incredibly data intensive. And so this is why I think for semantic technologies, this is a big, big challenge and a very good opportunity for showing that sometimes research can also be very useful in real life. So I put a partial list of official information sources, data sources for creating taxpayers' profiles. But actually, what I've been told is that these days, one of the most important sources is not this one, but is what people themselves write, for example, on their social networks. Because you have people saying, oh, my income is 10,000 euro per year, and then they put pictures of their super yacht somewhere, or their brand new Ferrari they bought, or their house in the mountains, whatever. So these kind of things that people do in a very naive way actually are becoming more and more important to understand the lifestyle and the basically standards of life of people, and try to build a more realistic profile with respect to what you have in official records, like databases from the tax agency. So to address this complex scenario, what we did is to use a combination of traditional ontology-based data integration. I don't know how many people here are familiar with semantic technologies. I will say a little bit about it, but the time is short, so I will be very quick. Okay? But we also have used one of the core assets of the Ocan company, which was developed in a European co-funded project called Ocan. So the story is, there was an idea, there was a research project funded by the European Commission, there was a startup company, now the company is trying to do some real business in applying these technologies in this scenario. It's not the only scenario, but it's one of the most interesting. So this is a map of my region, just in case you want to know where it is. We are in the heart of the Alps, so in the northern part of Italy, not very far from Austria, by the way, but we are very different from Austrians. They pay taxes, we don't. Okay? The idea is, as I said before, that there is a high number. I just put a few databases here, but it's really hundreds of official data sets available for this kind of profiling of taxpayers. I'm sorry, the list on the right-hand side is in Italian, but I really don't know how to translate exactly in English. But some things are quite obvious. For example, we have the people registry. The first one, the anagraphy, is people registry. Okay, you have in every city. Or you have, for example, the tax registries, which is taxes you paid in the past, or the property registries, the buildings or the land that you own, or the car registry, like the cars you have, if you have any. We also have the databases of utility contracts, so electricity, water, gas, supply, whatever, and so on and so forth. So there's plenty of potential information sources. What we did in the project was to do two things. First of all, was to harmonize the meaning of these sources for machines, for computer programs. This is what you do with semantic technologies. You start from very heterogeneous data sources, for example, database tables, Excel files, or even text documents, and you try to provide a common vocabulary, a language, which can be used to describe in a uniform way the different content or the different sources. And so this is what we've done at schema level integration using ontologies. So we designed a few ontologies which can be used to represent the exact content of each information source in a harmonized way. So I'm giving a stupid example, but for example, if in one source you have first name as a column in the database, and in another one you have a given name, which is a different attribute name, but it's the same information, this is harmonized and linked, mapped to the same property in the ontology, so that now the system can understand that this information is exactly the same information in the different sources. And you can do this not only for types of objects, for example, say this is a person here, this is a building, this is a contract, this is a payment, you can do this, but you can also do it with relationships. So if, for example, somebody is married with somebody else, and this is represented in a different way in different sources, you can create a relationship married with, and you can map the information from the different sources onto a single relationship. So the result of this step, first step, is that you have a virtual knowledge base, a unique knowledge base, okay, where all the information is used to build this large-scale knowledge system that you can use then for tax investigation. The second step is more related to our technology and is a very, very well-known problem that you find in many distributed applications, which is, okay, you have harmonized the schemas, but then how do you know that some information refers to the same entity, to the same thing in different information sources? This is a problem that was also mentioned this morning by Professor Mustafa Jarrah. The only thing I understood, because there was some English text on the slide, they had an entity server. I think the purpose is more or less the same, that you must have a common way of naming things in different sources. Otherwise, you might not be able to put together information about the same taxpayer or the same company or the same building or the same contract from different sources. And this is what I try to depict here by putting faces, buildings, and whatever. And we used this infrastructure called entity name system, which is the technology which was developed in the OCAM project, where basically what we do is very simple. We take, well, I think I have a slide. Okay, I will say in a second. I have a slide explaining what we do, which is much easier than just discussing the picture. The result is that from the different sources in different formats, so it could be a database, as I said before, an Excel file, or an XML file, or whatever it is, what we do, we build a graph, and this is again the result of using semantic technology, a graph which does not correspond to any particular source, but is the integration of this information in a very natural way, where you put objects, as building blocks, and you connect objects with relationships coming from different sources. So in this example here, the idea is that maybe you know that the lady is married to the man from the people registry, okay? But maybe you know also that the same lady owns a building, okay, from another source, the property registry, and that the guy owns a boat, maybe from the boat registry, and that since they are married, you can start to putting together information, and maybe you discover that there is a supply contract for the house, but I don't know, but they don't pay tax on the house, whatever, and so you can navigate across this information basically without having to bother anymore with where the information was stored at the beginning. So this is the virtual integrated knowledge base that we want to build using ontologies and the entity-centric technologies. This is a very concise description of what I mean by entity-centric. An entity is any object you may have information about. So, as I said, a person, an organization, a building, a product, a contract, whatever is an entity. You can name it, okay? And actually, as we know very well from the web, the real value of information is really when you have connections between entities, across entities. And this is what we're trying to exploit, okay? So, the knowledge base we are going to build is basically a graph like the one you have seen, which can be browsed and queried in an intelligent way, and can be also extended in a flexible way, because when you have this entity-centric view, okay, adding information about an entity is very simple. You don't have to bother with the original database schema, with the XML schema, with the Excel file. It's really a matter of adding links, okay, from one entity to other entities. And this can be done in a very flexible way, as very efficient in terms of costs. Okay, so for the project, as you can imagine, the project had exactly the objective of starting from the data available in the region, perform some data cleaning, because I don't think this is just in Trentino, I think it's a general problem. Very often data are not very clean. These data have been created for many, many years with different conventions by different people using different systems. So for example, in Italy we have a code called the fiscal number, which is similar to the social security number in the US, that in theory should be everywhere to identify a person, but in practice it's not like that. In many places you don't have this number in the database, you have the wrong number in the database, so it's really a mess. And this is the simple example, just with this code. Just imagine addresses. Addresses is another nightmare, because there are hundreds of different ways of writing the same address, different conventions. So the first step, which is very important, is sorry, I just pressed by mistake, the data cleaning in a source, and what is called record linkage, making sure that at least in the original sources there are not duplicates, okay? Because that's the other thing. Sometimes the same person is registered twice or 3 times because there was a mistake maybe in the fiscal code. So these things happen, okay? Second, the integration that I already described. And third, the objective of the project is to create simple rules that can be used by tax inspectors to identify automatically good candidates for inspection. Because you understand that if you have 500,000 people that or companies or whatever that you might want to investigate, you cannot do it systematically one by one. You need to start from the most likely candidates and then go ahead, because this is by far more efficient. And this is not easy as a task. So this is just the same representation, but a bit more pictorial of the project, from the data cleaning to the mapping of the ontology, the identification of entities, the creation of RDF, which is the semantic web format for representing graphs, okay, on entities with ontologies, the creation of the data storage, okay, and then the main functions, which are searching, navigating, reporting, and filtering on this knowledge base that we have created. Okay. How much time I have? Yeah, so I will just go a bit faster. Okay, let me. Okay, this is for the important part. Okay, what I will tell you here is that it's very simple. Maybe you already understood the idea. So we have created a tool starting for Google Refine. How many people know Google Refine? Just very few. And then this is a very powerful tool that you can use for many things, which has been bought by Google before it was called another way. But it's incredibly powerful to do some simple operations on large or many types of data. So you can load, for example, a table from Excel or a database or whatever, and you can split values, you can correct mistakes, you can do many things, and you can add plugins. And what we did, since this tool is very simple to use and very powerful, you can also use it to reconcile entities with external sources. In Google Refine, you have a built-in functionality to reconcile with Freebase, which is another knowledge base, public knowledge base on the web. But we have created tools basically to import the data sources we have available. You can see on the left-hand side. From Google Refine to reconcile with the entity name system so that we can always find, if we already have an identifier for an entity, and use that identifier, not another one for the same entity, to store in the triple store, in the knowledge base, and then to pass the information for the navigation. So this is something very interesting and very powerful. This is the algorithm we use for the entity name system, never mind. There is only one idea here, is that if you really try to assign to each entity the same ID, one by one of the sources, not in a systematic way, but one by one. When you do that, then the data integration using graphs is incredibly fast and powerful. You have it for free, basically, which is a very interesting feature of semantic technology. Okay, let's go ahead with this. This is the interface for the alignment in Google Refine between the original schemas of data sources and our ontology. You do it basically with a few clicks, or you drag and drop names from the ontology to the from the original schema to the ontology. So really, in a few minutes, you can start from a data source, reconcile it with entities, map it on the ontology, and generate the RDF graph and store it in the knowledge base. Okay. Search and navigation. We have a navigation tool. This is, sorry, I deleted the names because I cannot show publicly the names of the people that we have in our data. Okay. But this is just to say that now this virtual knowledge base can be navigated and can be searched using a very powerful faceted-based browser, which means that you can select a lot of filters and combine filters, and basically, without knowing the query language, selecting entities that have some common features like person, of gender male, born after 2000, which lives in this little city and whatever. Okay, good. And you can also do the same thing using maps as a paradigm. Instead of using tabular queries, you can also navigate across the map and select the entities that you are interested in. There are many benefits from this approach. From the technical perspective, the key thing is that you don't need to modify the original sources, that you have one key for entity in the entire system so that you can access information very quickly. You can add new sources in a few minutes, and it's really scalable. And it is ready to be published as linked data, which is another big thing. 2 minutes, but I'm done. Just 2 slides. For the user, basically, there is a huge increase in efficiency. You collect information not in a month, but in a few minutes. There is a very natural model behind it because we are used to think in terms of entities and connections, not in tables. We don't think in tables normally, okay? And we made experiments with the tax inspectors. They find it very intuitive, instead of just learning the schema of the table. The free navigation is a very important feature for them because tax inspectors don't believe in a system that automatically will find the evaders, but they believe in a system that will give them information that combined with what they have in that knowledge in their mind will help to find the evaders. And so they like it very much, this free navigation, and there is a significant cost reduction in management in managing data, and we made a comparison with another solution using data warehouse techniques. Conclusion. The project is in progress, so we cannot provide a full evaluation. So it will go in production in the next couple of months. So I cannot tell you. I would be, I would not be honest to say, oh yes, this has been a big success. We have the first tests with users. They're happy. The efficiency of data collection has improved by orders of magnitude, but we don't know about the effectiveness, which means, okay, how many actual tax evaders will be identified in a given amount of time. We know how many they identify today. We need to prove that using the system, that we'll be able in the same amount of time to basically recollect more tax evasion than before. And the project is going to scale up to a bigger national project because we are establishing a partnership with the biggest software house in Italy to expand the solution to other public administrations and maybe to the entire country. This last sentence was an animation because this is something important. Sometimes making good use of a technology does not necessarily mean that that technology will become very popular. And I don't think we will become very popular in our region after this application because people don't like to pay taxes, okay? But I think it's a good application because if everybody pays less. At least this is the idea. Okay, here's the partners and the people who work on the project, and thank you very much for your attention.
Thank you, Professor Paolo. We will leave the question to the end of the second session. حتى نوفر وقت بس شوية. الآن المتحدث المهندس إياد قمصية، مدير عام شركتي BCNC وشركة باولو ونائب رئيس مجلس الإدارة، حاصل على شهادة الماجستير في الهندسة، يعمل في مجال IT من 21 سنة. أدار العديد من المشاريع الناجحة في مجالات الدفع والدفع المسبق. أهم المشاريع اللي هو مشروع قبول بطاقات الائتمان في فلسطين ومشروع أنظمة الدفع الإلكترونية من خلال شركة باولو. تفضل.
يعطيكم العافية. بحدثكم اليوم عن شركة باولو للدفع الإلكتروني، تأسيس الشركة، أهداف الشركة، إيش الخبرات اللي أخذناها لغاية اليوم، إيش المشاريع اللي طبقناها، أنواع الدفع الإلكتروني اللي دخلنا فيه لغاية الآن، وين إحنا واصلين وإيش نقدر نعمل أو وين متوجهين في المستقبل، وكيف نقدر نساعد مشروع الحوكمة الإلكترونية من ناحية الدفع. الأجندة تبعتنا موجودة لأنه فيش وقت كثير بنمشي عنها بسرعة. نيجي للبند الأول اللي هو تعريف عن الشركة. شركة باولو تأسست من قبل بنك فلسطين وشركة BCNC بالشراكة بين الجهتين هدول. الهدف اللي هو تطوير أنظمة الدفع الإلكتروني، دراسة السوق الفلسطيني، إيش الحاجة للدفع الإلكتروني وكيف احنا بنقدر نغطي جميع شرائح المجتمع الفلسطيني بحيث يستفيد من الدفع الإلكتروني. نرفع شعار اسمه ميد ان فلسطين لأنه المضبوط كل اللي شاركوا في تأسيس الشركة سواء برمجة أو هاردوير أو تنظيم الشركة أو تأسيسها ومجلس إدارتها كلهم فلسطينية بحت. وطبعا احنا بنفتخر بهذا الشيء، خصوصا انه احنا وصلنا مرحلة نشتغل مع شركات عالمية زي فيزا وماستر كارد وماشيين مع الليفل اللي هم بيطلبوه.